Hello everyone! In this video we're going to be talking about the basic concepts of arrays. In our last chapter, the chapter on files, we talked a little bit about strings. We said this is how you can declare a string, and for the most part we kind of left it at that. Strings are declared with the data type character, a name for the string, and a size in these square brackets. Well, a string is a special type of character array. And so all arrays are declared the same way with the data type for the array, a name for the array, and a size. So arrays can be thought of basically as collections. So an array of integers is a collection of related integers. An array of float is a collection of related float values, just like a string is a collection of related characters. So this declaration always looks the same. We have our data type, and this can be any of our basic data types. So it can be an integer, a character, a float, or a double. The variable names follow all of the same variable naming rules that we talked about for basic variables. The square brackets, and then the size. And the size can also be any reasonable value, but it does have to evaluate to an integer value. We need to know how many integers, floats, doubles, etc. are going to be in our array. So for an example, suppose that we wanted to store information for a running program. People go out and run a certain number of miles, say 3 or 5 or 15 or whatever, and they want to record the time it took them to run each mile. We could have a individual float variable for each mile. We could have like mile 0, mile 1, mile 2, mile 3, etc. But suppose we have a really avid runner using our program, and they like to do marathons. Marathons are 26 miles. So we would need 26 individual float variables to store all of that information, or one array of size 26. So this would be the collection that we would create. All of these float values are related. They're all times to run a mile. They're all float values. So we could have float miles size 26. Here's a look at a way to kind of visualize that. An array is a collection of individual values. So each of these green boxes is a different element of the array, a different value that we store. So we could do the first mile in the first box, the second mile in the second box, so on and so forth. So the length is the number of boxes that we have. In this visual, there are 10 boxes, so the array length is 10. We use the index of the array to find an individual value or element. So if we want to access, say, this particular box, we're going to use the index for that box. Now, the valid indices of an array go from 0 to size minus 1. So in this case, the array length is 10. So our indices are 0 through 9. We always start at 0. So index 0, index 1, index 2, so on and so forth. If we want this particular element, this is the element at index 3, just like this one's the element at index 8. The index is going to get us to the right box or element of the array. So if we're working with that miles example, where we have an array of size 26, the valid indices are 0 to 25, 0 to size minus 1. If we wanted to access the first element, then we would use index 0, because we start counting at 0, we go up to size minus 1. So miles is the name of our array. The index we want to access in square brackets, so miles at index 0, is the very first element of that array. And since miles is of type float, we know that the element at index 0 is also of type float. And so we can use this anywhere we would normally use a float variable. So we can use that for reading in information in a scan format function, printing out information in a print format function, using it in an arithmetic expression. Anywhere we would normally use a float value, we can use an element of a float array. So for an example, if we wanted to take the average of 4 miles, then we could add the element at index 0, the element at index 1, the element at index 2, and the element at index 3, and divide by 4. And that would give us the average time for the first 4 miles. Like any variable, we would want these to have information in them before we start using them. So an array, just like any other variable, needs to be initialized. The primary difference is that when it comes to an array, we need to initialize each element of the array. Rather than just one thing, we have to initialize everything. So for something of size 26, we're going to have to initialize 26 things. Initializing an element of the array is pretty simple. We would do it just like any other variable. We'd say miles at index 0 is equal to whatever initial value we'd like to give it. The difficulty comes in doing this for all of the values of the array. If we know the values that we would like to initialize the array to, then we could initialize each of those values individually. So this example shows something that is only of size 5, which means there's only room for 5 values inside this array. It's also declared as an integer. So this particular one, this array declaration, says we're creating an array called miles with room for 5 integers. And our indices are going to be 0 to size minus 1, so they'll be 0, 1, 2, 3, and 4. So if we know the values that we want to assign to miles, we could go ahead and do that explicitly. We want the first element to be 5, the second one to be 7, the next one to be 6, so on and so forth. But of course we wouldn't want to do this for 26 values or 100 values or even more. We could use a shortcut that looks like this. This will do the same thing as the previous slide. Here's all of our initial values set up in a set of curly brackets and separated by commas. The first element will be 5, the second element will be 7, the next will be 6, so on down towards the end of the array. But suppose we wanted to initialize everything to a default value, like 0 or even 1. We wouldn't want to type in 26 zeros or 100 zeros or more, so instead we need to think of a construct that allows us to do things over and over again. And that repetition comes from loops. So we can set up a for loop to run the length of the array, which is called traversing the array, to traverse the array and set each of our values to some initial starting point. So in this example, we're initializing all of our values to 0. It's a good starting point. We have a counter I. We start I at 0. 0 is the first index of the array. We let I go until it's strictly less than size, incrementing by 1 each time, so that our values for I will be 0 to 25, which are the corresponding valid indices of the array. And then we'll use I to index the array. That's why we use I. I stands for index. And for each iteration, we'll go to the ith index of the array and set that value equal to 0. So when I first starts out, when I is equal to 0, since 0 is less than 26, we'll go to miles at index 0 and set it to 0. I will increment to 1. And 1 is less than 26, so we'll go to miles at index 1 and set it equal to 0, and repeat for all 26 values of the array. So let's take a look at what traversing an array looks like. We'll do a couple of short examples. This program is just going to demonstrate what we've been talking about, how to declare, how to initialize, and then how to print an array, because we're going to want to be able to see the contents. We'll stick with the same examples we've been working with. This will be miles of size 10 to experiment with. Anytime we're working with an array, we're probably going to want to counter. So for right now, we'll go ahead and do our array float miles size 10 and our counter integer I. To initialize the array, we're going to let I take on all of the values of the indices for the array. So we'll start I at 0, and we'll run I until it's strictly less than size, incrementing by 1 each time. And for each iteration, we're going to set that value of the array equal to some initial value. So now that we've got initial values, we're going to print them out so we can see what they look like. So we're going to traverse the array. Remember, that just means starting at the beginning and going to the end. So we're going to start I at 0, the very first index, and let it go to the last index, which is 9. And at each iteration, we want to print the contents of the array, and we're also going to print the index. So the index is I, and the value comes from the ith index of the array. So the index is index I, and the value, these are float values, the value comes from the ith element, or the ith spot of the array, miles at index I. So we're going to run that and see what it looks like. We should see for each element of the array that it's been assigned an initial value. We'll also see the indices 0 through 9 for 10 things that are currently equal to 0. So let's make that look a little bit more interesting for our second example. Instead of 0, let's do something like I times 2. So now when we print it out, we're going to see some different values. See 2, 4, 6, up to 18. Okay, so now that we have some contents of the array, there's a couple of different things that we could do. At the moment, we're going to stick with printing examples so that we can focus on traversing the array. This one prints from the beginning of the array to the end of the array. So we're also going to do one that goes backwards. We're going to start at the end of the array. The last index is size minus 1, so the last index is 9. We're going to go to the beginning of the array. The first index is 0. We're going to go down 1 each time. We're going to continue printing the index and the value so that we can see both. So the index and what's at that index of the array. And then between the two, I'm just going to put a little bit of separation so that we can see that a little bit easier on our output. So now we've got one that prints all of the values forward from beginning to end, and one that prints all of the same values, it's the same array, starting at the end and going to the beginning. In our next video, we'll see how we can get inputs from the user. Instead of creating our own, we can get information either from the keyboard or from a file. And we'll also do some other things with numerical arrays, like finding the average or looking for the minimal and maximal value. I'll see you then.